Hello everyone. A couple of months ago, I tried to solve the Sudoku solver, which is a 3Q Codewars exercise, and I was struggling a little bit, so I left it alone. And a few days ago, I tried again and started from scratch, and I I was able to solve it finally. I think it took me uh, over 2 hours to solve it. But I liked the end result because the main part of the program is in just a single line of code, which I liked is array functions chained together. And after I finished, I made a small bot using Puppeteer to access a website to extract the puzzle information into an array, have the algorithm solve it, then uh, write the solution back into the website all automatically. And I also liked that result. So I will show you my logic, and I will show you a couple of examples of the bot solving the Sudoku puzzles. I want to point out that this is the kyu Sudoku solver by Pineapple Clock, and it's the easy one. I think there are a couple of not so easy ones. So this is the terminable, meaning there's no need to guess. Uh, so you will find at least one position into the puzzle where there's only one solution. So it's not that complicated. Okay, before we continue, there's a spoiler alert because I will show you um, pretty much all my code. So if you want to solve it on your own, you should stop looking at the next part of the video. So this is the puzzle as you will receive it. Okay. Um, so my logic is this: you receive the puzzle, and while it's not solved, you will find in this nested force, because you have to check. I wanted to check every position and see uh, the possibilities of the numbers that can be placed into that position into the puzzle. So if there's only one possibility, I will write it down and continue again until the puzzle is solved. I, I included a max cycle, so there's only 100 cycles as a fail safe, just in case I run into an undeterminable puzzle. So let's see at what the find possibilities function uh, actually does. So this is the important function, and after thinking a little bit, I realized that what I wanted to do was to simply uh, type all the numbers and filter the numbers that are already there and remove those. So for example, let's take x equals 3 and y equals 1. So that would be this position. So what we need to do is find out which numbers are into this row, this column, and this mini square, and remove them from our number list. So these are the possibilities which we start with. And let's start with the row because it's the easiest one. So we will want to filter all these numbers by using this particular row, and we want to check that every element into the row is different from our numbers. So in this case, there's the number 1 and number 2, so those two numbers will not pass the filter and therefore will be removed. Okay, so that was the easiest part, and this took me actually a little bit, but then I realized the next part it's also a filter, and there's no need to start with all the numbers again. So we will filter starting from the remaining numbers, of course. The next part is the row. So before we run our filter, we want to map our puzzle and only keep the elements that have the same index as our x. So that will return all these numbers. We want to flat them to have a one-dimensional array, and we will have the same as we did right here, and by coincidence the code is almost on top of one another, and this as you can see is exactly the same function. We want to check that every element into this new array is different from the remaining elements into our number list. So we have 3, 4, 8, and a 9, so those will be gone. So by this point, we already have 3 possibilities, and we finally have to do the same filter, but with the numbers listed here. So this was the most challenging part, because before running the final filter, we need a slice of the puzzle, and I realized that by dividing by 3, flooring it and multiplying by 3, we will get for index 0, 1, and 2, we will get 0. For 3, 4, and 5, we will get 3. And for the next part, we will get 6. So by making this slice 3 positions, so 1, 2, and 3, we will get this subarray or this slice of the array. And then we will have to map that new subarray and filter the index so that the index is bigger than, again, this operation, but now with x, and less than 2 positions more. So finally we will get this slice of the array. We will want to flat it to get a one-dimensional array, and finally we will be able to perform the same function as before, that every element into this array is different from our number list. So there's 1, 8, and a 9, and they are no longer into our list. So for this particular position, we will get these 3 possibilities. So as you saw in the in the code before, we will want to find a, a position where there's only one possible solution to write it down. So without going into much detail, I used Puppeteer to create this small bot to test my algorithm into a real website, a real Sudoku website. So this is the website that I found would be easy for me to create a bot for. So I opened the website. I had to increase the timeout a little bit. Maybe my computer is slow. And then I extract all the information from the Sudoku table or board. And after getting the solution with the previous algorithm, I type it back. And that worked well. I will leave a couple of examples here so you can see. And if you want to check the code, I will leave a link into the description for my GitHub page. So I hope it was useful for you. Goodbye.